Hi, this video is about probability distributions. So we're going to take a look at how you can determine whether something describes a probability distribution or not. First, we need to talk about some definitions. The first one, a random variable is a variable typically represented by x that has a single numerical value determined by chance for each outcome of a procedure. A probability distribution is a description that gives the probability for each value of the random variable. It is often expressed in the format of a table, formula, or a graph. A discrete random variable is a collection of values that's finite or countable, so it doesn't mean that it can't go on forever, it only means that you can count it. So the example that's here is how many times you have to flip a coin in order to have it land on a tail. And so that potentially could go on forever and ever and ever, but you could count how many times it takes you to do that, no matter how long it takes. A continuous random variable has infinitely many values, and the collection of values is not countable. So something that's impossible to count, so something like someone's height. Anything that's represented by a decimal typically would be something that is continuous and something that we can't count. Next, we have the requirements for a probability distribution. There are 3 of them, so all 3 of these have to be met in order for something to be considered a probability distribution. The first one is that the random variables are numerical values. The second one, this symbol it means sum, and so this is the sum of p of x, or the sum of all the probabilities, is equal to 1. So add up all your probabilities and you should get a sum of 1. If not, then it's not a probability distribution. Every great once in a while, because of some rounding errors, you may get a sum that's something like 0.999 or 1.001, and again, that's because of rounding errors, and that would still be considered a probability distribution if all of the probabilities added up to one of those 2. Next is that each of the probabilities need to be between 0 and 1, so that's what this means. 0 is less than or equal to p of x is less than or equal to 1. And it's inclusive. It includes 0 and 1. So we need to have probabilities that are either 0, 1, or something between 0 and 1. Now let's take a look at some examples. So here we're just going to take a look at one example of a couple having 2 children. And the kinds of things that we did in chapters 2 and 3 was we looked at what it would look like to take a sample. So go out and ask families that have 2 children how many girls they have and how many boys they have, and then put that information into a table, and we could calculate the mean and the standard deviation from that. So this was collecting a sample and calculating some statistics and creating some graphs about that information. In chapter 4 we calculated some probabilities, and now in chapter 5 we're going to create a theoretical model of expected results and then find the parameters. And the parameters are the mean and the standard deviation. So that's given there for us. That's going to be our very first example, is to determine if each of the following describes a probability distribution or not. And the first example is about the number of girls in 2 births. So is this a probability distribution? So we need to figure out if it meets the 3 criteria. The first one is that the random variables are numbers, and that's true. The second one was that the sum of the probabilities has to be equal to 1. And our probabilities are 0.25 plus 0.5 plus 0.25. And that does give us a sum of 1, so that one checks out as well. And the last one is that all of the probabilities have to be a number between 0 and 1. And all of these probabilities, 0.25, 0.5, and 0.25, those are all between 0 and 1. And so we do have a probability distribution. In the next example, in a Pew Research Center poll, subjects were asked if the use of marijuana should be made legal, and the results from that poll have been used to create the following table. So in this one, right away, we break the rule because we have yes, no, and don't know as our random variables. So the very first condition is broken. So let's see if it meets the other two criteria. The next one was that the sum of the probabilities is equal to 1. Our probabilities are 0.41 plus 0.52 plus 0.07. And that does in fact add up to 1. So condition 2 is met. What about condition 3? Are all of the probabilities between 0 and 1? And that is true. All of these numbers are between 0 and 1. But number 1 is not met. In our next example, senior executives were asked when job applicants should discuss salary, and the following table is based on their responses. So the first condition, are the random variables numbers? And yes, they are. Number of interviews, 1, 2, 3. That's RV in short for random variable, in case you were wondering. The second one is that the sum of all of the probabilities needs to be equal to 1. And so add these numbers up, and do we get 1? We can already see that we're not going to, because 0 plus 6 plus 0 is 6, and so we can't get a 0 in the end, which we would need. And then 3 plus 2 is 5, plus 1 more is 6, so we get 0.66. So that condition is not met. And the other one is met, the last one. 0 is less than or equal to p of x is less than or equal to 1. So all of these probabilities are numbers between 0 and 1, but number 2 is not met. So this is not a probability distribution. Because the sum of p of x is not equal to 1. In our next example here, we're given p of x is an equation. So p of x is equal to x divided by 3, where x can be 0, 1, or 2. So we need to make up a table of this probability distribution, or, well, we're not sure if it's a probability distribution or not, but so we have x and p of x. And remember, p of x is x divided by 3. So you take x and divide it by 3. 0 divided by 3 is 0. 1 divided by 3 is 1/3. And I would just leave it as a fraction and not put it as a decimal because it is a repeating decimal. And then 2 divided by 3 is 2/3. And again, leave it as 1/3 and 2/3. Don't convert it to a decimal. Now let's check our conditions. So the first one are the random variables numbers, and they are second one is the sum of all the probabilities equal to 1. And we have 0 plus 1/3 plus 2/3. And 1/3 plus 2/3 is 3/3, which is equal to 1. So that condition is met. And the last one are the probabilities between 0 and 1. And they are. We have 0, 1/3, and 2/3, and all of those are numbers between 0 and 1. Okay, so that's it for this video. I hope you guys are having a great day, and let me know if you have any questions. Thanks.